Today's review is about probability. The first definition you need to write is what probability is. Probability is the chance of an event occurring. So the fraction that you see below there represents how we form probability. The numerator is the number of ways that event could occur, and the denominator is all the possible outcomes. When you see something like the complement of an event, that's talking about the event's opposite. So for example, if we're talking about a jar of marbles and we want the probability of picking a red marble, we sometimes use capital P to stand for probability. So the probability of getting a red marble and its complement, which would be the probability of not getting a red marble, some other color, we know that they're going to equal or add up to 1 whole or 100%. Sample space represents all the possible outcomes. So remember, we did a coloring activity a while back with pants and shoes. And we use what we call the fundamental counting principle. So we're going to list that as our example. Our sample space was 2 pant colors times by 3 shoe colors was equal to 6 different outfits. So that's called the fundamental counting principle. You can see you've got more information about that right down here below. To find your sample space, you can create a list, table, tree diagram, and you can also multiply. That's kind of the shortcut way. Okay, come over to the next box. We're going to talk about experimental versus theoretical. The experimental probability represents the ratio of the number of times an event occurs to the total number of trials. So it is based on data. Like if I rolled dice over and over again or spun a spinner, and we often see the data displayed in a table. So if we were to roll a dice or a number cube and it lands on 4, we could report how many times that happened. Or if we were testing out, you can see here like light switches, 3 out of 17, that would be an actual experiment. Theoretical probability, though, is based on all the possibilities. So I wouldn't necessarily have to use a real dice or a real spinner to get that. It is based on theory. So an example, the probability of rolling a 4 on a dice is 1 out of 6 because there's only 1 4 out of 6 sides. Or a 50-50 chance for heads versus tails on a coin, or 1/2. As the number of trials increases, meaning the more I roll the die or spin the spinner, the experimental probability gets closer to the theoretical. So we talk about with experiments, the more experiments I do or more trials I do, the closer those two get together.